Hey, 12th graders. So we are starting our Unit 12. Unit 12 is our last modeling unit that we have, and it is all about trigonometric modeling. So we call them periodic functions. You can see from this quick sketch or this like little snapshot of this curve that it's called periodic because it has this idea of a cyclical behavior to it. It's waves that go up and down. So things that you see with periodic functions, you see light waves, sound waves, radio waves. When we're trying to represent things that have cycles, so tides, like ocean tides, right? Temperatures that go through like ups and downs. When you talk about the motion of a wheel over time, right, you'll have that cycle of going around the wheel multiple times. So you'll see a Ferris wheel problem frequently throughout this unit, talking about this circle around the Ferris wheel. So periodic functions, they're functions modeling of sine and cosine. We only will be doing sine and cosine in this unit. We also call them, because it's sine and cosine, we call them sinusoidal models. And you'll hear me say that a lot because it's a fun word. So why would I not say it a lot? And also because that's technically what it's called. Periodic functions, sinusoidal models, they are functions for trigonometry. Things to look out for are phenomena that have a cycle. Phenomena. Do, 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 do. So phenomena that have a cycle, tides, temperatures, motion of wheels, or any of the other things that I mentioned earlier. So here are the parameters of a trigonometric graph or sinusoidal curves or periodic functions. And so these are going to be like the key behaviors that we look at, right? So we've talked about like axis of symmetry when we've looked at quadratic functions, and other things with other types of functions. And so here are the things that we look at when we're talking about these types of models, things that we care about. The first thing is that instead of having a vertical line of symmetry with sinusoidal models, we have a horizontal line of not really symmetry per se, but this idea of like you've got like an even balance above and below. And so you can see that like it's not necessarily symmetric. If I fold it on top of each other, it won't fold back onto each other. It would have a rotational symmetry to it, which means it wouldn't have a line of symmetry. It would have a point of symmetry in which you could rotate this graph and it would rotate onto itself. But there's this line, it's called the principal axis. And it just cuts right through the middle. The principal axis actually splits up the next thing that we're going to talk about, which is your amplitude. So your amplitude is this green line right here. And your amplitude is only the height from your principal axis to either the maximum or the minimum. So the whole height of the graph would be 2 of the amplitude. So your amplitude is going to be always evenly split between the principal axis. So your principal axis is in the middle of your total height of your sinusoidal model. And amplitude is only one of those, just from the height up or down. The last thing that we talk about, the last key behavior of sinusoidal models are the period. And the period is how long it takes you to complete a cycle. So you can see here, we started the cycle here, went up, down, and then we got back to the beginning of the cycle. A lot of times, though, we don't look in the middle here because it's hard to see. The easiest way to see how long the period is either going from the maximum to the maximum or the minimum to the minimum, because those are easy to spot, right? So imagine that this guy continued up. The maximum to the maximum would be one complete cycle. So we arrived back to where we were, or the minimum to the minimum. And that distance is always the same, whether I'm looking at this distance or this distance or this distance. That distance is always the same, and it is the number that is the period. And the period represents how long it takes us to complete one cycle. So the principal axis is the line that kind of cuts through the middle. I imagine it as like this string that kind of just like holds together the wave as it goes across. The amplitude is how tall the graph is, but not really the total height of the graph, just half of that height of the graph. And then your period is how long it takes to complete one cycle. So those are all the things that we care about with sinusoidal models. So we're going to investigate this together by looking at these guys on a graph. I encourage you to get out your calculator and go along with me, just because we're going to be practicing a few like key skills when using our graphing calculator when graphing these sinusoidal models. So we're going to do the first three together, and then I'm going to have you do the last three on your own. Getting out your graphing calculator, let's go ahead and graph. Let me first get to a standard zoom, because I'm assuming you guys are all going to be at a standard zoom. Let me get it so it's not blurry. And we're going to go ahead and graph this guy, 2 times the sine of x. And we're going to look at A, how do we get our zoom to be in the right zoom? And B, how do we find the amplitude, period, and principal axis by just looking at the graph? So when you first graph it, it just looks like this. And we know that anytime we graph something with sine or cosine, it's going to be waves. So a few things to keep in mind, like a key thing, a key window trick here is that we could do zoom fit. But zoom fit, well, it's because I've got another graph in there. That's why. But zoom fit might not necessarily get us to something that's helpful, right? It still doesn't look like a wave. And this happens to us all the time, right? When we do zoom fit, we're like, oh, that's not helpful. So a few things to keep in mind, that the original, the parent function of sine and cosine is that sine can't go above 1 and can't go below -1 or cosine. That the values of sine and cosine never go above 1 or below -1. If you want to know why, it's actually a pretty cool relationship within mathematics. It has to deal with the fact that sine and cosine are ultimately right triangle trigonometry relationships of side lengths and right triangles. And so we could talk about that together in class if you'd like. But so we know that our y values, if we go to our window, will always, not always, but is a good place to start, that your y values should be between -1 and 1. So I'm going to do -1.5 and +1.5 to try and like get that visual just a little bit above and a little bit below 1 and -1. And then to complete one cycle, when we're talking about one cycle of a circle, when we're talking about one cycle in general, it tends to be 360 degrees, right? This idea of like one cycle is 360. And remember that your x values represents the cycle, the period, how long it takes to complete the period. And so for the angles that we put into your trig functions, right? The idea of one complete cycle of an angle would be 360 degrees. So on your x-axis, we're going to start with something slightly below 0 for x minimum, and then our x maximum will go slightly above 360. So 370, 380, 390, or 400. So these are always a good window placement to start when you're dealing with trig functions. So this is like a window trick when you're trying to get to see your trig functions right away, is to kind of go in and just understand that like, okay, normally it's between -1 and 1 on the y-axis. And then on the x-axis, completing one whole cycle is about 360, because we're talking about degrees when we're talking about numbers inside of a trig function. And the idea of a full cycle with degrees is 360 degrees. Okay, so we put that in and we see the curve a little bit more, but we're not all the way there. It's because that this is not the parent function. We're multiplying by 2 here. And so there's something going on here in regards to the transformations that we need to account for. So now we can tweak our window a little bit. So I'm going to go back and say, okay, the window was almost there, but not quite. I need to make it a little bit taller, and I want to see one full cycle from maximum to maximum or minimum to minimum. So I can either make my x minimum kind of scooch a little bit more to the side, or my x maximum scooch a little bit more to the right. And I also want to just like open up that y value a little bit more. So I'm going to go above my y values, and I'm also going to expand my x values. So I'm going to go back to my window and say, okay, x minimum, I'm going to keep that there, but maybe I'll go to like 450. I don't know. I'll try it out and see if it works. Just because I want to go a little bit more to the right. And then I also want to expand it a little bit more vertically. So I'm going to do negative, I'm going to just double it, -3 and +3. and see if that works. And it does. Now I can see a little bit more. Notice the maximum's not quite all the way there. So I don't know if I'm actually at the maximum or just barely there. So I'm going to just really quickly tweak one more thing with the window settings and do maybe like 500. And now I can definitely see that maximum there. And so I can get a full picture of this wave. So these are all things that you're going to have to do when you're graphing your trig functions. Okay, so I want to know the amplitude. And remember that the amplitude is the height from your principal axis, the very, very middle part here, up to the top. And so I want to get a few key points when I'm finding all of these things, the maximums and the minimums. Those are going to be some pretty valuable things to have. So I'm going to go in and I'm going to find, analyze graph, my maximum, boom, my minimum, and then I'm going to also get this maximum over here. Remember that you can just hit the numbers instead of like clicking down, 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 enter. If it's 3 is the maximum, just hit 3 and it'll do it automatically. So that's why I can do it so quickly, is because I do menu 6, 3, and that's all I have to type. And then I'm there. Okay, so amplitude is the height. So we're talking about, with amplitude, the y values, right? Those are the values that we care about in regards to our points. So amplitude is from 2 here. Notice we go all the way down to -2. So the total height is 4, but amplitude is only half of the height from here to here or here to here. And it's talking about height, right? And so it needs to be positive. So it wouldn't be -2, it would be +2. Okay. Then the period is how long it takes us to complete one cycle. And as I said earlier, the easiest way to see a complete cycle is either going from maximum to maximum or minimum to minimum. You could start at the middle point here, da-dum, 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 ba-dum, but I'm already looking at the maximum points. And from here, we're only looking at our x values, right? So we're looking at how long it takes us to complete a cycle, so the x values. So it goes from 90 to 450. So what is the distance between 450 and 90? Well, if I subtract them, that gives me 360, which you're like, okay, 360 is a full cycle of angles, right? So kind of making those connections there. Okay, so it's 360 is my period. No unit of measurement, it's just the period is 360. The amplitude is 2. The principal axis is the horizontal line, so it's always y equals a number, right? Because a horizontal line is always y equals a number, as opposed to your vertical line, which is x equals a number. So y equals a number, and it's that number that's smack dab in the middle. And so you're looking at those y values again, and what's the y value that's smack dab in the middle? In other words, the average of your y values. So going from 2 to -2, 2 to -2, the number that's smack dab in the middle is just 0, right? So in this case, your principal axis is just y equals 0. Okay, let's try it again. I'm going to go in and now just adjust this graph, and I'm going to do 2 times sine of, and I'm just going to put 3 and then enter. Notice that what happened is we multiplied by 3 on the inside, and then all of a sudden it kind of like accordioned the graph to be like whoop, right? It squished the graph together. So while we're multiplying by 3 on the inside, it insinuates that your graph is squished a little bit more as opposed to expanded, which you would think with multiplying that maybe it would expand in regards to transformations. But when it's inside the parent function, it's the opposite of what you think it is. Trying to remember and make those connections with previous lessons on transformations. I'm going to go in and delete these points because they mean nothing to me now. So I click on it and press delete.